what I'm going to do in the next maybe 30 to 35 minutes is try to give you a snapshot. And you will see many elements of the snapshots in the coming sessions, and maybe it will get repeated in different forms. But the point is, it's important to have this snapshot before you enter the depth of the workshop and other activities. I'm going to bypass some of the routine things like about C-SAG and all those things. I'll concentrate on the spatial analytics and give you a very quick overview of what we're doing in AgriGIS. So this is all you know. We are supported by Tata Trust and Bill and Melinda Gates Foundation. So we are a unique center, both on the knowledge side as well as on the societal impact side. I think you've heard of this in the inaugurals. I'm not going into the depth of this. So let me come to the core of what I want to talk. Spatial data is, just another data, except that we have been working with it, and we want to have that adjective called spatial data. It could be beautiful data, or it could be ugly data, or it could be banking data, or whatever. So it's just data. But the data has a very unique characteristic, and that is the locational information or the coordinate, what we talk of as coordinates in the data. So most of the spatial data that we talk of has to have the characteristic of a geolocational tag or a coordinate. And that is what distinguishes it from other data sets, which may not have this characteristic. So all satellite images, aerial images, unmanned aerial systems, data, topographic maps, thematic maps, positioning data, they all categorize and come under the umbrella of spatial data because they have that unique characteristic of location or geographic coordinates that are associated with them. So as a result, because this data has this unique characteristic of this attribute of the location or the coordinate, it is amenable to special types of processing, which would not be there for other types of data like say banking data or insurance data and all those things, which are highly tabular data. So that's where the spatial analysis becomes very important, and that is slowly emerging as a discipline which specializes and deals with the spatial data. And that all represents the logical processing or the logical integration or the logical analysis of the spatial data that we talk of, which comes from different sources and different formats, and the various difficulties that are associated with data are also associated with this spatial data. But then it utilizes the analysis and logical expression utilizes the power of the coordinate. And that's where the topology, distance, and the timestamp becomes very, very important. And these characteristics make it very important to understand the nature of the data that we have and the processing and the conclusions that one can draw from it. And these are all becoming front end of GIS knowledge today. So GIS, if it represents today, it's about analysis. When I started my GIS career, I can tell you it was all about digitization. Half my efforts in my research went into digitization of maps. And when I moved into the higher levels of my profession, the biggest challenge was to organize databases. Today, none of them are important. The forefront of GIS knowledge is analytics. And they're all based on the principles of data engineering and data science, which comes from the computing stream. That's the technology that is getting merged and aligned into the mainstream of deep learning that one can talk of. The concept is very simple in a geographical information system. It includes the maps, various data. It has a timestamp. You got different levels of data in the whole thing. It is amenable to visualization because it's highly graphic. So graph theory and algorithms can be easily applied to that sort of data. And advanced analytics and deep learning can be applied. And because these are all geo-referenced, it has unique autocorrelation. The data is all correlated. Land use is correlated to water body is correlated to temperature is correlated to climate change and all. If one can understand this correlation that is there, you get a lot of meaning and information that is associated with this. There's also proximity. Because these are all correlated data, I can find out what is near me, what is far of me, what is north of me, what is south of me, and so on. So these proximity analysis becomes very important in the analytic systems. And there is also spatial heterogeneity. The same data gets represented in different ways. For example, a district in a map or in a GIS also includes villages, and they also includes houses. So there is a tremendous amount of homogeneity as well as heterogeneity that's there. These are all very fundamental principles that one should understand to get to the depths of geographic data and their processing. And that's what most of us in our profession try to do. Spatial information, of course, is very much useful to everybody today. 30 years back, 40 years back, when I started my work, only government agencies were using it. But today, you talk to anybody, everybody uses spatial data. So I'm not going to go to the details of this, but just imagine 6 billion people or 7 billion people of this earth, they are the users of spatial data in some way or the other. Some more, maybe some less. What are the technology trends that are happening in spatial technologies today? The highest technology, the technology that's triggered all of this in the 1970s, as you heard in the inaugural session, was a collection of data. The satellites, the GPS sensors, or the aerial sensors, and the cameras, and the surveying instruments, total stations, all of this, they were the technology that triggered this. And they brought about a lot of technological upgradations today, that you have the most advanced data collection systems available to humanity. To the extent that each of you is a data collection system. Without your knowledge and without your awareness, you are collecting data and passing it on to somebody, and it's getting archived in the total data sphere that one is having. So data collection technology has gone rapid and tremendous changes, and today they are powering a lot of geospatial data across the world. And as I said in my remarks, it's just a small percentage of the total data sphere, but still it is a phenomenal amount of data that is coming in from satellites, from LiDARs, from ground penetrating radars, GPS systems, crowdsourcing, Internet of Things, and many other things of this one. All of this data is all getting integrated, and they are now suddenly becoming amenable to see as maps. So you can see the maps of Wi-Fi devices in Bangalore. You can see the maps of traffic. You can see the maps of population density. Any information is now amenable to graphic processing and display and visualization. That technology is becoming a very important element in the future of analytics and trends that is coming in. As a result of this, the analytics is being driven. Of course, this also is being triggered, as I said, by computing, which brought in data science, data engineering, artificial intelligence models, and other things. But these two have got merged now. With all the data that's available, it is analytics, the deep learning, the fusion, mashups, dashboards. These are becoming the principal elements of spatial analytics technology. And of course, applications are becoming wide. Each of you can develop an application with the spatial data if you want. It's becoming so easy. Governments are doing it, industries are doing it. So applications are becoming very, very wide in the whole thing. And delivery today is riding on the computing technology that we have in the internet technology. And you know, it's very easy to deliver all the information to anybody on the mobile devices and other things. So you will see that many of these technologies are getting seamed in. And in my own visualization, a day may come when spatial technology will not be a separate, rather it will lose its so-called silo significance that we have maintained till now. It just becomes part of data. So the next generation of experts will just look at spatial data as also one element of data. The technology is driving it and bringing about changes in a very rapid way. What are some of the spatial acquisition methods? Surveying, you're all aware of. I'm not going to go into those details. Satellite positioning is another thing. Variety of satellites are available. India has the IRNSS, GPS is there. They provide you basic principles of trigonometry. All of surveying and GPS is fundamental based on trigonometry. It is triangulation which helps you to define the coordinates and precision. So underlying this technology is the fundamentals of mathematics, statistics, graph theory, geometry, which is driving all of this. There are video imagers, you know, which do a lot of processing with GPS and other things. They not only get the X, Y, and Z, but they also get the object, because you're able to see the differences in the object. You can see where the building is, where the road is, where the car is, and so on. Road profilers are becoming very prominent using the same fundamental technology of triangulation, trigonometry. They're all fundamental to all of this. Similarly, lasers, you know, which is again another basic technology that is coming in through the physics, where you use a light, high intensity light radiation to detect objects and to see the variations in them. And that's extremely useful. A lot of data, distance calculation and angles are coming in through the laser technology. Of course, the aerial platforms are all of you are aware. You fly an aircraft with various sensors, you get a variety of data. Similarly, unmanned aerial systems today come with the power of being able to get data at will, at any time that you want on the whole thing. And ground penetrating radars can get you data below. And as I said, the most prolific method that is becoming is crowdsourcing. And the data that each of you generate, 6 to 7 billion people, is the tremendous source of future data. It is not only about you, it is about your location, it is about what you do, it is about what you measure, it is what you observe. A lot of things get associated in the crowdsourcing data set that are coming in. So I'll just skip this. There are some sample aerial images. You will get to see this. Unmanned aerial systems, the type of details that you get, the LiDAR data, which gives you height, elevation, digital elevation models, which are very unique characteristics of spatial data. You can get height instantly from all these data sets. And the type of data and the visualization that one can build with some of these data set is unique. And finally comes the satellite imaging. And satellite imaging is the one which triggered all of these things in the 1960s and 70s in the sense. Today the focus is that to image any part of Earth almost on a daily basis at high resolutions. That is a trend that is being taken in the satellite imaging industry today. So 25 to 30 centimeter resolution, the Indian remote sensing is there. There are foreign satellites which provide this, is becoming the benchmark. Just imagine 25 centimeters of data for the whole globe available almost every day or every 3 days is a tremendous amount of data that's going to be available. And some of these are becoming a reality. And that's where the high cadence. Cadence is the ability to manage, to image the same point as frequently as possible. And today's cadence is almost every day. So there are satellites which provide you data every day. And the second characteristic that is coming is analysis-ready data. When I started my work in GIS and remote sensing, it was a tremendous job to put the tape and get that satellite image into the computer and then do the classification techniques, supervised, unsupervised, and so on. Today, everything analysis ready. On your mobile, you just ask for this NIAS point, coordinate so and so, you get ready data which you can use for your analysis and decision making. That's the trend of what the technology is going to. And n number of satellites are coming in. I have just given some list you can see in the corner of the whole thing, n number of satellites which will provide images. It's just that you have to hunt them and sometimes pay for them. So that's the type of technology trend that is happening in these things. And the third thing that is driving all of this is the ability to bring in measurements of plots of land. Ultimately, as a citizen, what we own is the commercial enterprise that we are associated with. And the commercial enterprise that every one of us is associated with is my land, my property, my city, my society, my family or whatever. So unless you get to that plot of land, many administrative decisions that are required to be taken, many human activities that are to be transferred across time periods are not possible. But today, luckily, putting in the cadastral information into the GIS frame has become a reality. And many states, including of course Karnataka, Gujarat and many other states, they have digitalized all the land records and cadasters. So you have all the ownership data, you have all the satellite images and a host of other data, crowdsourcing data that you can put in. And as I said, the data sphere is blowing out and exploding in the whole thing. Moving from 35 zettabytes to about 170 zettabytes is a big job. And if one has to extract meaning out of this data, it can impact individual lives, it can impact individual nations, it can impact individual cities. So there's a lot of focus in managing this data. Even though one can see it as an explosion of data, but is well structured and well archived in the total system that we are seeing today. So this is the trend that is happening on technology. And one of the things that is spinning off because of this is the analytics. And these are some of the top trends in data analytics that we see today. And one major element is spatial analytics. How to handle all these volumes of data with the location tag or the geographic tag that is associated. And these are some of the top data analytic tools that are becoming important. You will get exposure to many of this in the workshop, and some of this you'll be able to apply with your own in your own systems in the hands-on that we are doing. For example, R is becoming one of the most prolific statistical and data modeling software which people are using for doing variety of data sets. And it can do the processing in spatial domain. So it has tremendous capabilities to do that. Python is becoming the fundamental script on which many of the scripting is going to be done on various platforms on the whole thing. ArcGIS, which is one of the strongest spatial analytics tools, is becoming sort of a standard for processing spatial analytics data and integrating various types of data with bridges in doing the interpolation and the sort of operability across systems. So n number of things are there. And the simplest tool for data analytics is everybody of you uses this is Excel. And I can tell you Excel has some of the most easy to use tools as far as analytics is concerned. It's not just constructing a table, but the amount of analysis that you can do is tremendous. And I think these are the tools that are powering of how data analytics is going to be seen tomorrow in the whole thing. So the spatial analytics domain also sort of is undergoing some change, and various types of data modeling is coming into reality. Things like map algebra, things like statistical programming in maps, things like three-dimensional modeling of maps, these are all becoming reality today. You can process this data using the traditional computing algorithms, the traditional algorithms of geometry and the data science that are associated with it. You can manage the data both in the XY domain as well as the Z domain, which could be above the surface or below the surface in that sense. Yeah, I'll just continue on so that we can catch up later in these things. So as far as geospatial data is concerned, another very important technology element which is very crucial is the ability to link the data which does not have a geospatial tag and link it up with some geospatial tag. So what is known as geotagging? This is a very important capability that's required, and tremendous analytics methods to automate this process is going on. For example, you may have millions of banking transactions. These are all data which is happening from a bank server and bank database and the whole thing. The question is, can I associate a geotag to it? Put in a tag of location so that I can be amenable to seeing them as maps or as dashboards. These are all easily possible. And I can assure you, any data that is available in the world today has the ability to geotag it. Your Aadhaar data, your PAN data, your credit card transactions, all of this are becoming geotagged. And one can sort of see the different capabilities to build this sort of data sets. So geotagging is another technology which is coming up, and a large amount of all the crowdsourced data is getting geotagged. The platforms on which all this technology is done is almost wide. We started off with mainframes, VAX 780s and so on, PDP systems and all. Today everything gets done on a small handheld mobile. So the range of, so the platforms are very unique in the thing, you know. So there are massive cloud systems on one hand, and the processing gets done on a small Android phone. So spatial technology, the limitations of hardware is all gone. There was a time when limitation of hardware was there. We used to struggle and say, oh, the RAM is not enough for doing all my map processing. Oh, the graphic, this one I can't do the processing and so on. Today, everything of that is gone. So all the spatial analysis is also benefiting from the computing technology that's coming in, and that making a lot of sort of advantage coming into others. For example, building visualization and dashboards is an easy job today. You have all data, you can just construct a dashboard within no time. You will do an hands-on in the workshop. You will see how you can generate visualization and dashboards very, very easily. You want to do a criterion analysis, this is very easy. Okay, if the land use of Bangalore is changing from this percentage to this percentage, the population is changing from this percentage to this percentage, then what is the impact for 2050? It's a criterion. You can build this criterion in structured language, maybe using some R rule or maybe a Python script, and you have all the analysis done, and you can look into the visualization of this data. You want to change the parameter and say, oh no, I don't want to use 20%, but I want to make it 40%. Just change the script and you're done with on the whole thing. You will see some examples of this in your hands-on that you're going to do. So, and deriving hotspots, you know, which are the places where all the changes are happening with the data that is there. Where are maximum credit card transactions happening? Which is a city where maximum Aadhaar indications are happening? Where is rainfall happening more? These are hotspots. If we can get the visualization of these hotspots, it helps us to decide on many governance things, many societal applications. So hotspot analysis is one of the strongest capability that one can do using spatial data sets and the whole thing. Varieties of hotspots we have generated around villages, around pollution points, around cities, around roads and so on. So you will see some examples of this when we do the applications also. And once you have all these hotspots, constructing graphs, bar charts, visualization, just like Excel. So you can put in many things, you can create your own dashboard, and your story is out to say, this is what is coming out from this analysis of the data set that you have. So building stories and building the capabilities, communicating it is also becoming very, very easy in that sense. The second important thing that spatial analysis allows you to do is the point analytics. You have a lot of point data. You have pollution points, you have got bus stops, you have got some other things, etc. and all. You can just spread them. You can create a spread map. You can create what is known as ranging. You can define the points and range them. You can model them and create them into hypsographs or choropleth maps and so on. And the ability to interpolate and then display it on a visualization, this is the power that the spatial analytics provides you to do. Combinative analysis is another thing, like for example, drive analysis. If I drive from here to Vidhan Sauda or to some other place, what is it that I'm going to view? So creating that view, creating the site analysis, creating spread analysis, these are all very important things when you do highway engineering or road engineering or infrastructure and other things. These are all possible in the whole thing. Segmentation Segmentation is a very fundamental tool that we use in spatial analytics. How do we segment all this data? Now, the segmentation could be of satellite images, it could be of elevation data, it could be of any other data that you have. There are methods by which it can be done. Earlier, it used to take almost an hour or two to do a segmentation of a satellite image. But today, all the segmentation gets done in no time at all. The algorithm is built in, the logic is built in, and you just run the images and you get out the results. You will see some examples of what we do. Here is a small example of how we segment satellite data for mapping paddy in South Odisha. You will see these examples when we do the extraction, when we do the hands-on. Feature extraction is another major activity on the whole thing. You get so much of data, but how do you extract those important features, and what are those important features? For example, in a city, I may get a satellite image, but I want to extract the boundary of all the buildings. I want to extract the roads. I want to extract all the water bodies. This feature extraction technology and the analytics that one does is a very important capability that provides us a lot of information which hitherto is there in the image, but you would not be able to get it out for your decision-making process. So, for example, here is an example that we did of buildings and then extracting the boundaries of those buildings. Classification is at the core of data analytics. Any classification of satellite images where you take different images, correct them for the radiometry, geometry, and other things, bring them to a common base or a common threading benchmark, and then classify this image. For example, satellite-based image classification is classic, and we get information about the different classes that one gets, and there could be clustering algorithms, or there could be non-clustered training set-based classification algorithms, and there are methods of doing this in a very systematic way. Some examples of this you will also have in the hands-on. Converting statistics to map is one of the biggest power of spatial analytics. You got some statistics, it could be population data, it could be the amount of credit card transactions in the city, or ward-wise complaints that are there of citizens. Converting them into maps is so easy. And some examples of this you will hear later on. I know that Dr. Vishnu Chandra has done tremendous activity in some of these applications that are there, and NIC benefits a lot of this power by converting the data that they have. Change analysis is another core. Any change in data. What was the situation in 1985? What is the situation in 1990? This is the power of spatial analytics, because the data is structured and it is already time stamped. You can do a lot of change analysis, and we do tremendous amount of change analysis, saying what was the land use of Karnataka in 2000, what is the land use of Karnataka in 2017, what changes happened, where has forest reduced, where has water reduced, which part of agriculture area has been lost. So this change analysis is fundamental. And these are all done autonomously, as was being mentioned earlier. Automatically, all of this happens, the algorithms are set in, and the power of the data analytic tools allows you to do this sort of a thing in a very significant way. Let me run through some quick applications that are there on the whole thing. For example, groundwater mapping is one major activity we used to do in ISRO. But today, for example, we can just do a groundwater diagnostics. You give me a coordinate of your farm or your land. There is a method of getting a groundwater diagnostic. Just like you get your medical diagnostics, you can get a groundwater diagnostic for the piece of land. That is the power of analysis and communication that happens as far as applications are concerned. Master planning, smart city. Many of you users must have used this. You can easily get the changes between the plan that was there earlier and what should be proposed. Here is an example that we did in the city of Mysore. How to construct a master plan and project it to the people for the future. So this sort of activity is very important. Power distribution, which is one of the major applications that the power companies use. For example, what happens if a transformation failure is there? This is the total network in a city, and then this transformer fails. Immediately you know which are the houses that are going to be blacked out, what to do for that particular transformer, how to reroute it, and so on. Land acquisition is another major application where this GIS and spatial analytics is used. You want to acquire land for some purpose. So you can integrate the satellite images with the cadastral data and then identify, saying that I want to take this route. Here are the parcels of land that have to be acquired. Earlier, this was a big cumbersome exercise, but nowadays, it can be done very easily because all this data is available. Election dashboard. In Karnataka, the Karnataka Election Commission uses GIS to bring out a lot of election data and election dashboards during the elections. So I just want to show the range of applications that are done in the GIS today, and it is tremendous. Talk of any human activity, whether in the public space or in the private space, there are applications that are getting developed, and we all must benefit from the power of this particular technology. Finally, let me come to the final things of what we do in AgriGIS, and just to give you a snapshot. Our main aim is to support farmers using the technology of spatial analytics. So we don't worry about what the government wants, we don't worry about what society wants, we only worry about what a farmer wants. What he wants is what we want to deliver. And our main thrust is also deliver it in the language in which he understands, not deliver it in the language that I know of all the processing, clustering, classification and all that. It should be easy to understand advisories that should be made available to the farmer. Whatever you want to do, your technology, do it agnostic to him, do it behind, but present him an advisory which he finds it really useful. That's the thrust that we have taken in AgriGIS. And we have done this over 2 years now, and we are getting ready for the next year, which is the Kharif 2020, and we hope to cover about 130,000 farmers, as being said, and administer the advisories to them. Basically, the model which we use is the classic model of spatial analytics. We reduce every data that we can lay our hands on, we reduce it to a plot of land that the farmer has. So if you can reduce the weather data, if you can reduce the satellite image, if you can reduce all the other data sets that are available, terrain, water, land use and so on, and bring all of them broken down, disaggregated to a plot of land, then that data is the one which can really be useful to the farmer for making the advisory that's required. And this involves a lot of data engineering and a lot of data analytics steps to do this sort of a thing. And we have done this. Just imagine a massive Excel database. All the farmer names are written on one side, and then we have all these parameters, hundreds of them written down every year, third year, fourth year. This massive data is what helps us to determine what would the best advice to give to him, what crop he should show, when is the weather likely to affect him, what is the type of market that he needs, and so on. This is what we do in this particular activity. So we take all this processing and we provide 5 advisories. A pre-harvest advisory, which is before the harvest, and what should we advise for him to sow, and 4 advisories during the cropping season. A cropping season is about 120 days, so roughly it means 1 advisory every month. And at the end of the exercise, we go and do an audit so that we can understand what we have done, any impact that is there to him, what is the benefit that he has got, and so on. So this is a broad model that we have for doing this activity. So ultimately, you will hear all of this in subsequent talks, but GIS and spatial is all about integration. It's about integrating not only the maps and so on with other data sets, it's about integrating our needs with your needs, it's about integrating this technology with some other technology, it's about integrating resources, it's about integrating the innovations in thinking that is required, but all of this integration with one purpose to bring some change to some group of society. In our case, we deal with farmers. Maybe tomorrow somebody can do this exercise for urban people. Somebody can do this for the underprivileged. Somebody can do it for people who are uneducated. But ultimately, if we can bring all this integration of technology and achieve one social goal, which is to help society to emerge better than what it is today, is what GIS is all going to be about. And today it is possible to do this sort of a thing. So minimize the cost, improve the efficiencies that are required, and enhance services to society. So broadly, lastly, I would like to say, in our vision, spatial analytics must be a national requirement. It should be a national program. It has to embed into every aspect of societal workforce or governance activity that is there. It should become a part and parcel of the workflow of every government employee, of every activity that is going to be taken up. And that's going to be a challenge to do that sort of a thing. Computing also went through the challenge. There was a tremendous resistance to computers in the 70s when computers were brought in and people wanted to work on computers and computerize and so on. There used to be tremendous resistance. I think that change has to come in where everybody starts using it in a big way. And it must become a national resource. Why should India not have all its geographic data available so that anybody who wants to use it, anybody who wants to develop applications on it must be able to do it? Why does I have to struggle to build a database, do applications, and then ultimately go and do the service? It's like saying you want to enjoy driving a car, but first build a road yourself, and then you drive the car. I think this is the chain that we are looking at in the government. Hey, you build the roads, so you build the GIS and make the data available. People are there to build the applications. That's the vision we have, and I wanted to share with all of you. In the subsequent talks, you will hear a lot of this, and many applications will be talked of. And I'm sure we should be able to trigger a lot of discussions on what analytics, what technology is going to take us forward, how to build different types of applications. And of course, you can learn a lot from what we have done in AgriGIS, and we can learn a lot from what you people think on the use of spatial analytics and deep learning in GIS. Thank you.